Alright, so our sampling distribution for the difference in means. As I mentioned in the PowerPoint, your sampling distribution for the difference in means is a t-distribution. So when the samples are large enough, it's normally shaped. If the samples are small, it accounts for that by putting more area in the tails. For the purposes of what we're doing, I'm just going to draw it to look like a normal distribution like I've been drawing. Alright, so this is our sampling distribution for a difference in means. And come back to that in a second. So when I talk about a difference in means, I'm talking about the difference that you get when you subtract one sample mean from another sample mean. So in order to do this, we're going to be working with examples that have two samples. And we'll refer to the mean for sample 1 as x bar sub 1, or if we have a name for the sample, like if we're talking about a sample of male police officers, that could be x bar, and then instead of writing a 1 here, you'd just write out male here. Kind of up to you how you want to do the notation. For sample number 2, we'll have a different mean, and we'll refer to that as x bar sub 2 in a general sense, and then if you want to write in, again, the specific group, so if you wanted to say x bar female, if you're talking about the mean for female police officers, you can do that as well. But the key here is that we have two different samples when we're thinking about a sampling distribution for the difference in means, and they each have their own mean. So, yeah, so this could be the sample mean for whatever male police officers you're looking at, and this could be the sample mean for whatever female police officers you're looking at. But we're talking about samples here, so this is the subset of cases that you've drawn from your larger population that you have in front of you. The difference in sample means is what you get when you subtract one sample mean from another sample mean. So difference here is just difference in the mathematical sense, where it's the outcome of subtraction. So if you have one sample mean and another sample mean, you can always find the difference. What a sampling distribution for the difference in means plots is the different differences you can get, which are described by this x bar sub 1 minus x bar sub 2. So you take a bunch of samples, you can get different values for these, which means that your difference comes out to a different value. And here we're always plotting the difference in sample means, and then the probability of getting each one. So how this sampling distribution is different from the ones we've seen before is that instead of having just one sample mean here, we have a difference in sample means. Because of the hypothesis that is the basis for the two-sample t-test, where we're looking to see whether the overall difference in the population is 0, the mean for your sampling distribution for the difference of means, so your overall mean, the one that we write here and refer to as our overall mean or our sampling distribution mean, it's always going to be 0. Because we're always going to be looking at a world described by the null hypothesis in which the two groups we're looking at have the same mean, and therefore have the same difference in means. So you could also refer to this as mu1 minus mu2. So you're saying in the population, your population mean for one group minus your population mean for another group comes out to 0 because they're the same. So with the sampling distribution again, we're describing a world in which, in our example, male police officers and female police officers use the same amount of force in the population. So if you subtract the mean level of force for one population from the mean level of force for the other population, you get 0. So when we're looking at a sampling distribution for the difference in means, we're always going to have this overall mean of 0. Unlike the standard normal distribution, though, or the standard t-distribution, there's a standard error for a sampling distribution for the difference in means that isn't set to begin with, and that'll be based on characteristics of your sample and the variable.